Every month we will build, or we have to build, as long as we believe that every human has the same right to have a good space, and on a level, I would say, of a Western European level of the 50s. And if we're following this challenge, then we have to build every month a volume in comparison to New York. So this means it's a huge volume of physical space. And at the same time, we have to answer the question how we can do this and reducing our consumption of energy and emission. This is related to this challenge. At the moment, building construction is using 36% of the energy worldwide, and our emission is roundabout for CO2 emission is roundabout by 39%. These are quite big numbers. That means the building industry, that means we as architect engineers, we are really responsible for how we can develop this planet further. So we are not something in we have a quite relevant profession, and we have really relevant questions to answer. And one of the typical issues in this all complex is are the materials. And now because over the 20th century we were starting to use this high strength materials, steel and concrete, and this materials somehow quite problematic, because they, especially cement, is responsible for 8% of the CO2 emission. That means if we're building like we do this at the moment, right at the moment, so we're increasing this problem or this challenge more and more and more. That means we really have to stop this, and we have to find completely different answers how we build human space. We really need a turning point in creating physical space. That means we have to change in absolutely dramatically way, that we changed this 150 years ago. And one answer is the use of technology, and one answer is innovation, of course. So if you're looking, so what are possibilities to reduce the CO2 emissions? There's one answer that the technology can really help us to solve this. That's a key contribution in this challenge. As the same for the question of resources. If you're looking on, especially on concrete and reinforced concrete, now I think it's more and more a common knowledge, but it's still not really in our practice. I think we don't really realize this in our practices at the moment, that sand is a finite resources. It means we have a real problem in a global scale with simple material sand. It's a very present problem in the Asian part of the world, maybe not in Europe, but as we see this as a global question, and we have to think about how we can reduce dramatically the incorporation of sand in all this production of physical space. And the interesting thing is that we have to do this, what we have to do much faster than we do it at the moment. We must become better and faster, and we have to, what we do, and we have to do it really right now. So I think as an engineer and an architect, I would say the best answer is to really change the way in the early design stage how we design buildings, because this is also quite common and quite well-known analysis that the impact of design concepts of the reduction of material consumption and emission of energy and CO2, you have a very great impact in the early design stages. And you lose more and more of your possibility for real impact as the design process is going further and further. And then it's starting cost and material increasing more and more and more. That means our aim should be to do what we have to do in the early design stages. And if you're looking again to our daily practice, then you can see that we are not there at the moment. No? So we don't exactly this, not at the moment. No? We don't really spending enough time in the early design stages. No? We're starting quite too fast, or very fast with design concept not really good and analyzed, starting too early with the realization process. So this is, I think, is a very common problem, and this is, I think, is also our idea and our hope that we can change this very fast, because it's not it's just a changing of a process. The second idea is that we really have to come in architecture and engineering to a modal design. That means we really have to use computation as a method and as a possibility to answer a complex network of questions at the same time. And we have to do it in an iterative way, how we can do it with the use of computation. And we have to answer mechanical challenges. We have to answer all the climate questions, and of course, spatial questions. We have to create spatial quality, looking on the performance of the human space, really on the performance in the multi-modal concept. So I think this is a very important point for us, that we're saying, okay, the architectural design should be really focused on a performance idea, performance concept, performance of a spatial and different spatial performative ideas. And I think computation is therefore, I think, exactly the right answer to come to new concepts. And then a third idea is that we, for inspiration, we should have a look back. I think not only to the master builder of the Gothic cathedrals, I think it's also always worth to looking back to the Romans, because they developed a lot of very interesting solutions or concepts with less energy impact. So they were, of course, they were able to build huge spaces, wide spanning structure, using with not high strength material, more low strength material. And they were using this in a good combination of a deep understanding of the materials, like the Roman concrete, and it also a good understanding of structural forms. And in the end, they were able to create fantastic spaces like the Trajan Market in Rome, or the well-known Pantheon, where you can also see that they were using this Roman concrete in a very, from our contemporary perspective, quite sophisticated way. So they were really trying to develop the design based on a deep understanding of the materials and how they can use the material. And all this, in comparison to another hero of the last century, Pierluigi Nervi, lead us to the idea to use digital fabrication and computational design to answer finally a simple question: how we can create floors with 30% less concrete, because this is still, I think, now we're spending a lot of concrete in ceilings. So if you're looking on the amount of material for, I don't know, for a high-rise building, or even for a building with 6 or 8 floors, the majority of the material is going into ceiling, because we're wasting a lot of concrete just we don't really use the material finally. No? And Pier Luigi Nervi was one of the master builders of the last century, who, as an engineer, but also as somebody who had a company and who was forced to find economic answers all the time. He developed his method of kind of prefabricated elements as lost formwork in combination with additional concrete in situ then. And so he created his kind of composite reinforced concrete structure, well known and different, of a lot of examples like this Palazzo de Lavoro in Turin. And if you are looking on the idea of that we can now enforce this concept with the possibilities of digital fabrication, we think our target is really to reinvent this concept from the architecture of the modern. So I think everybody knows this very simple example of this idea. You have a primary structure, and you have this flat ceilings, and you have the columns, and you have the foundation. So it looks somehow quite simple, and it has a very great impact in our aesthetic understanding. What is a transparent architecture? And I think we have to rethink exactly this point, no? Because this is one of the questions that lead us to all this material intensive way how we create at the moment architecture and physical space. And I think one change is using concrete printing, a bit unusual probably maybe for our work, because we spend a lot of time just with lightweight structure, developing form finding method and so on, and over the last 10 years. But I think we have really to answer the important questions. And I think that means we have to reduce the amount of material that we are using at the moment as soon as possible, because we are running out of time. And this was also a kind of turning moment for us to see this as our real question that we have to answer. And therefore, we were starting to work with concrete printing as well, and discovered that there's a good chance to create a completely different design language. But more than this, you can also use this design language to find a better structural performance. And this is, I think, what we are really interested in, to combining a new aesthetic language, combining this with mechanical and acoustic and thermal performance of a physical space, of a boundary physical space of a structure. So our first experiments were more, we were creating, as some others as well, concrete columns, using this possibility to create completely unconventional shapes in the combination of a robot and a concrete nozzle printing this free form column, which is now a part of the exhibition at the Futurium in Berlin. And this lead us to our challenge last summer term. We gave our students a task to develop a new ceiling system using free shape, free form. But it was very important for us to say, okay, you have to optimize your system that is to a modular system. You have to explain the construction method. And of course, you have to find a way how you can print this. And in the end, the idea was that we are able to print the best concept or idea at the end of the summer together with the Swiss company Sika. And a very important constraint from our side was to say, okay, it is super important that all concepts can show that they are able to reduce the volume of concrete by 30%. we gave this as the first idea. What's the idea behind the whole thing, that we're trying to develop this kind of new thinking for this question, how we can develop heavy ceilings for buildings. We gave a lot of constraints to help the students as well, to say, okay, it might be a good idea to work with this idea of prefab in combination with to produce this prefab maybe on site, then add in situ concrete, so reduce the mass for transportation and reduce the volume for transportation, to find also a new kind of hybrid manufacturing on site, a bit following the idea of Pierluigi Nervi, who did this as well, but just with human forces. So this was our introduction for the students, and then we had in the end 8 teams who were developing different schemes and concepts. These are the top 4, I would say. And just to show you a bit how far the whole process were going. So the students, this was one of the group. You can see this is on the right side above. The group, they developed this, I would say, in a very simple and robust concept, but we were super impressed to see that we try to solve more or less all important technical issues with this architectural design. So one very important point was that this was something that we developed together with Sika. This is that we have to print a ceiling in a vertical way, because to have the option to develop a shape, you can't do it on a flat ground, because then you are relying on the gravity forces on your concrete, printed concrete, and to have a more flexibility and to be as a more design freedom, we developed the idea to print in a vertical way. So this the students adapted this concept and came up, but with basic idea, maybe a bit in the following the concept that was shown at ETH as well, not to have more or less free-formed underview of the ceiling and ribs above. But in our case, it was very important to develop the system in a way that we don't have reinforcement in the ribs, just on the top of the ribs, so that the whole thing can work under compression, and the tension is just in the upper layer of the structure or of the ceiling. So here you can see another important task was that all parts could be transported and could be assembled on site, more or less with less technology. You can see the level of details. So this, we were trying to bring all these 4 concepts together and a kind of final rework, and we're trying together then with all the students together, so our final prototype that we would like to print with Sika. We changed a bit the boundary conditions to make the whole experiment more fruitful for us, to show, okay, we are able to print something with a shaped boundary. So it means we switched the design from this rectangular floor plan to a more or less free shaped floor plan, more as a challenge for us than for other reasons. Then we came up with the style grid to make this idea of the ribs a bit. So we did some structural analysis. We're shown here now. We were using Karamba, so we train our students to use Karamba. We are using Karamba by ourselves as well, exactly for this kind of experiments or design developments. We did some optimization, topology optimization. So I would say on a basic level, just following gravity, of course. Yeah. So the final shape of the whole mock-up was developed by this, I would say, quite simple topology optimization. And this was the final result. And then the final challenge was really to develop a printing path. So it's a bit like always, you can create form and shapes. This is not the question. The question is, in this case, I think this is super important also for the future, that we always really think about how we can build this, how it's possible to fabricate this. And therefore, you need some practical experience, of course. This, I think, is one of our biggest challenges for the future, that we can use a lot of digital tools and digital processes, but we need still physical experiences, implicit knowledge, if you want, to come to the right solutions. In our case, it took us a while to develop really this printing path concept using different speeds, and using this underlying the weaving concept to create with one nozzle in one go with different speeds this shaped boundary and this diagrid. So now it looks quite easy, but it took us a while to come up with this solution. And finally, we were able to print a first scaled mock-up. And now we are looking forward to develop this concept further. We will do this. Now we will try this summer to incorporate also acoustic optimization as well. To really come to this multimodal design state that we are looking for. And then we will do a full prototype. And again, this is a very complicated or complex process now, because you have to make sure that the prototype is under construction, is stable under gravity. This should also strong enough without any reinforcement, and under construction as long as the concrete is come into the lost formwork. That means this is just a game of gravity, and then finally we'll add on the top the reinforcement to enforce the whole structure for asymmetrical loads and so on and so on. So I think this is still something that is not completely solved, but we are. I think we think we're on a good path, and it's quite amazing how far we are now with this technology to create in a very short time quite complex geometries, and can start again to think about shapes and geometry and texture in reinforced concrete structure. That means about complex geometry, but we don't have to solve still the formwork question, because we can create this in one process. We can create it with one material, formwork, and final structure. And we hope this will lead us to this back to this possibility really to do this, that we can create a structure that answers a lot of questions, not only gravity. And I think this is my last point. It's super important that we really start to do what the first pioneers of computational design were saying, that the computation is made for simulating things, to do experiments, and to create a really fruitful combination of simulation, experimental work, and theory. And this will lead us, I believe, very strong to a new architectural language and new possibilities to answer these challenges that I mentioned at the beginning. And of course, the computer shapes the theory. This is a quote from Argyris, one of the computation pioneers from the 60s. And I think it will change our processes quite dramatic in the next few years. So thank you for your attention.
Yeah, thank you very much, Christoph. I think I would not have any questions. Do you stay a little bit with us?
Yes.
Yeah. So then we'll pass on directly to Alexandre, and it's very nice because you're both talking about experimentation in the academic field, which is going to also, of course, asking questions like Mette did yesterday evening on what is our role in the academic field and how do we treat it? What is the experiment? What is research? What is the student's role? What should we be as next teachers, or what should the students be learning? Should they just be learning tools? And so I think these are a lot of things that come back into your presentation. And Alexandre is, of course, he's an architect, a trained architect from the ESA in Paris. And he is a teaching member at IAC in Barcelona. Very experimental school in many ways, and I think I will leave the word to him. He's going to be much better than I am to explain all this. I think, Alexandre, you can take the screen if you try.
Yes. Thank you very much for inviting me. Pleasure to have the occasions to join you for this. Let me see if it works. If I share my screen. Do you see my screen?
Not yet. I see that the screen, with me, the screen of Christoph is still on.
Strange. I could share the screen, but it's true that before
coming.
It was frozen with the one.
It's coming. Yeah, it's there. It's perfect.
Yeah, good.
Great. Okay,
great. So thank you very much for inviting me. Always a pleasure to see the great work you're doing, and actually looking forward to see the finals. I have maybe to say in half an hour, so a bit of guidelines is always welcome. I understand that you just mentioned the discussion about like academics and industry. A preoccupation I have quite heavily in my work, but in general the entire institute. I have just a doubt about, now I see in the comments some interest also more like from the engineering side. What is the profile of the students? I was imagining architects, but now I have a doubt if it's not like a mix.
People that are online are coming from everywhere around the world, actually. So it's not
as you are. So
there's
that's good.
Yeah, there's people from the office of Polling and Goma.
Maybe I will try to accelerate then to keep. I will try to accelerate to keep space for some questions then, so that we keep it open. I will flip through some of these questions. No. So you were mentioning about the fact that IAC is a bit peculiar. I totally agree. I've came here as a student 10 years ago and get trapped in this wonderful place that is, in my opinion, one of the best places in the world to make a very strange experiment about construction, a lot of liberty and creativity, and a collusion between academics, industry, and spaces and technologies. We have like these 3 different laboratories around Barcelona, one in the middle of the nature, another one in the former warehouse. And we have the chance to be able to really mix a very broad range of disciplines and scales that, in our opinions, could converge into a better built environment. So we have this multidisciplinary and multiscalar approach to this world, something I enjoyed a lot because I came from France, where you had actually a very big distinction between architecture and engineering. And I'm one of these few strange aliens in the system that had studied both architecture and engineering at together with NPC. So never in the right corners. So I enjoyed a lot this space. IAC is effectively, as you mentioned, a kind of also like mix between academia and industry, and we offer like so much different ways of collaborating: research, education, development, promotions. We all believe that these are ingredients for promoting this goals that have this foundation that's called IAC. Where we try to promote this advanced architecture that for us is like how new technology could help a better future. No, we have a lot of classes and teaching. That's a big core of our center, but not only. Just wanted to mention we have like 2 programs in particular that actually is focusing on robotics and another one on 3D printing. That actually I extract some of the work of the students that have been developing together with the faculty in this presentation. So to show really this collusion we have between researchers, students, industry collaborations, and we enjoyed a lot this kind of open innovation frameworks. No, so we have actually collaboration with many people here. I forget to put actually more academia with who we collaborate. This is more like focus on like the industrial partnerships. But we enjoyed really lots this open format. Sometimes in France, unfortunately, I felt there was this big distinction between academia and industry. Hopefully, is moving away from this, and I think, Klaas, you're one of these examples that show how we can relate these two worlds. And also, we have we have a host of Fab Lab Barcelona that maybe help a lot of ideas around open source project, open source machineries, sharing knowledge, really this idea that we can create a community of people that want to learn and want to use this technology for a better world. This Fab Lab network now is huge, with more than 1,600 people around the globe pushing these ideas. We have Fab Lab Barcelona, so it's a bit bigger, very focused on architecture, while we see that this technology can apply to many other fields. But I think it's good to put this in the context of what means architecture. No, I see some chat going on. Let me just remove this 2 seconds. Up. I will put it in the bottom. Okay. So I think you've seen already a lot of presentation previously, so I will not insist too much. I just want to make focus on what's changing for architecture. We're integrating more and more digital technologies, allowing us to manage complexity in the most extraordinary ways. We initially been inspired by other industry. We didn't invent any of this technology. Actually, we use them from others. For example, Aerospatial was the first one. The first softwares we could integrate really easily to develop a building streamed from design to fabrication. In this case, it was the fish sculpture by Frank Gehry in Barcelona. That was one of the first BIM integration, but it was coming from the aeronautic world. So therefore, the language, the shapes, the cuts, the definitions were coming from this world. No. Today, we are trying to reinvent our own, the one of architecture, with our own set of tools, our own set of people. Everybody speaks about BIM, but nobody agrees on what should be in this BIM and how we should actually deal with it, especially when we go out of the traditional standard buildings and we start to go into like trying to innovate and to be different. So we believe that we shouldn't let others define for us the software, because we think that's the core of these elements. No, and not only software, but a whole set of mechanisms. We want to feel comfortable with this technology, and that's something that is really incredible, is that today's our new generation of architects, engineers, designers, but also industrials feel much more comfortable with coding, much more comfortable with scripting, and with managing data, flows of information, and all of this. So this is part of the context we have in our context of Ajax in general, but I would say worldwide. No. Also, we have more and more access to technologies to fabricate, and that's also very fantastic. It's more and more common to have a laser cutter, CNC machine, or 3D printing in the School of Architectures, but in general in small laboratories around the world. Same with robotic arm is starting to spread quite impressively. I think the Robot in Architecture Association took to map more than hundreds of these schools around the world, and I think these numbers are growing. We're a bit peculiar in IAC because we started 10 years ago and started to have like a huge panoply of very large scale elements, and we started to apply them to a set of projects, no? And we explored a lot what could be done. And what is interesting is we promote this methodology of actually getting access to the technology, getting comfortable with it, and starting to produce project with it. Now, so I wanted to show you a couple of projects of how we can use them. Some are a bit old, but I think they're good examples. No, for example, how we've been using simple laser cuttings to streamline this idea of origami shapes for a restaurant close to our schools, where we could actually eat often. Very good friends. Where we decided to finally redesign entirely the roof, the walls, the furniture, the tables. Everything was done with CNC and digital fabrication. Cost us a bit of time to develop, but now these are released in open source and allows any shops or restaurants around us to actually ask us any origami shapes. I think in a matter of hours, we can model it in 3D, just these planes in space, and we have already all the script ready to detail all of it, put it plain, cut it, and being able to install just 2 to 3 days after we had this meeting of space. No, so we have like this embedded knowledge of the designers of the ship that is something we can share, we can construct on top of it, that is really impressive. In this case, a very simple project, but successful still to be able to change, for example, the depth of the origami according to the acoustics. No? So close to the kitchen, we wanted a bit more depth, and we tried to make a diffusion of the sounds in one direction, while in the other direction, we try to get more flat to get more space to ventilate. So this is how we can deal with design architectures while understanding fabrication constraint in a very simple project. And you can imagine this, how it could be used in many other contexts. No? Another type of project, for example, was the Solar House competition for Decathlon in 2010 in Madrid, where IAC took the lead in trying to demonstrate that it is possible to fabricate an entire building open source from CNC machines. So kind of a first version before the Wiki House was out. They have done a wonderful work to then create this whole business, not business, but like this whole foundation around the Wiki House. But this was like kind of the first of like, okay, we can do it. We can do a building open source made of CNC panels and assembled together. In this case, we also demonstrate that you could optimize the shape according to the locations of the algorithm given. You could choose in which country you live, and therefore the shapes will adapt to that, as much as you could also choose how much square meters you want, etc. We actually win a prize of the public for this, but not win the first prize of the project. Nevertheless, we got more people interested by such projects of how can we integrate design, performance, and sustainability into a more modern architecture. No? How we can use advanced technologies to develop new type of architecture thanks to this. So this was the second version, so maybe more about like density in the city. We are looking here at the pavilion developed for Endesa for the smart city exhibitions. So this was a control center for Barcelona, instead for 5 years as a temporary building in front of the beach of Barcelona, really in the center. And very good example also of how you could have like just this simple script of negotiating views of the windows, while the solar gain through this kind of folds that is finally detailed till all the connections, that the CNC is streamlined and very fast. No? So to produce, so all the development that happened in this project is now could be spread really easily to an entire building. There's many other projects. I will not go too much along to them, but there is possibilities from the softwares to actually optimize geometries, to optimize matter, to reduce in general impact, and kind of fuse this let's say performance-based design from engineering with classical tool of the architect to understand space and element. So I think is very interesting how we can combine many ideas within this. This Vault before was done thanks to RhinoVault developed by ETH, but also like locals from Catalan world in Barcelona that invented this thin Catalan vaults, how we call them. We also had worked with Acciona to 3D print the first bridge, pedestrian bridge, in Madrid, together with Enrico Dini. Here we looked at topology optimization, even if the technology was very at the beginning, so the resistance of the material was not yet there, therefore is not so thin yet, but hopefully this have changed already now. And we've been also exploring other type of single line extrusions of materials, more for like thermal performance and ventilations. So how we can integrate those performance in the system thanks to this kind of collaborative tool. A project that makes us famous as well in the use of technology is certainly that we could push the boundaries of, let's say, limits of physics. In this case, we've been working after, I believe, 5 years in IAC with like novel type of 3D printing. We were always fighting against gravity and the process of fabrications. So this project developed by Sasha and Peter in collaboration with Judith Lardman studio, Synetly was pushing the limit of like, what can we do with robots? If we tune the material, if we tune the design, we Synetly being able to have full control of these systems and able to create these new geometries that we couldn't see before. So quite exciting moments, no? But this makes us come back to these problems like, but wait, why are we using all these technologies? No, is it just because we want fancy building, because we want like fancy shapes, we want always the novelty of these things? And we love this citation from Cedric Price that mentioned technology is the answer, but what was the question? And often we are a bit in this situation when we all want 3D printing, we all want robots, but sometimes we forget a bit why. So that's a bit the focus we've been taking as researcher. Now I will show you a bit more like a bit and pieces of research that we've been developed in EAC that not necessarily end up yet to entire buildings, but should be in soon, to go a bit into a journey that we are pushing us, but also our partners in Europe to rethink digital fabrication, to try to answer some of the big questions we have in construction, where there's still a huge lack of adequate housing. We're still emitting a lot of CO2 and generally really energy consuming just in the use of the building. And these numbers yet doesn't account another extra 6% of the CO2, worldwide CO2 emission just to be able to construct this building. So a lot of savings that are possible here. And in general, we want to avoid this answer of the mass-produced building that we kind of fear, of this kind of architecture and cities that we've seen especially in Asiatic country, and hopefully will not happen again, but might in Africa. We want to propose a more fine-tuned architecture that adapts and be customized finally. No? So we're looking at possibility of this technology to deliver fast and cheap construction, sustainable ones, and especially customized one to the client's needs, to the culture, to the location, to the site. And here we've been pushing a bit the logic around these elements, and together with the FabCity initiatives that we succeed to make sign already more than 20 cities and regions around the world, we want to push this digital technology to be more sustainable, helping in these circles, the circular economy, where finally the materials could be feedback at a much more local site. No, so trying to go out of the linear movement, linear economy, where there was too much trash, and trying to go into a circular one. No, you can recognize the Fab Labs here, and we believe there's like different scale of operations. No, for object, for design, probably a Fab Lab would be a good size. And if we look at like more large construction, like buildings, we've tried to make a building out of a Fab Lab. We not necessarily recommend it. It's quite difficult. And we believe there will be a lot of potential as well for a small and medium enterprise to go into like Industry 4.0. So that using these digital technologies, but not so much in the do-it-yourself, but a more professional and specialized way. No? And the idea is at the end is try to avoid this transit of matter locally, but think about like more global exchange of data. No? So more like at the global scale, try to avoid this. So what is this Industry 4.0? No, I think that you already had a talk with Akim Menge, so we'll not go too much in detail. But these ideas of like new technology are changing the world. And mainly, I will simplify it by saying that we have now connected device, connected information, and not isolated, specialized so much information. So we actually a lot develop systems, open source, like based on ROS, that is a robotic operating system, that allows to integrate open source academic ideas into the industrial world with like heavy duty machinery that normally are really closed source and difficult to enter. But certainly it allows a lot of communication, and we can, during the pandemics, we've been controlling the robot from our house. So at home, working, and the robot being in the labs, doing the experiment for us. We could control this through cameras. We had new type of interface. So this is really interesting modes and moments to be into it. No? But what this means in construction, we believe this means new interaction between the core elements of what means constructions. And here I simplified a bit in this diagram, thinking that actually it's about related design, machine and materials together in a more symbiotic ways. No? It will cost us a bit of change in the way we think, in the way we produce, in the way we adapt. But I want to show you a couple of examples that go in these directions. Maybe to simplify even more, and this is a bit conceptual, one way of looking at it is to imagine a robot that actually produces some object. There's some sensors that feel these materials and is capable to reinform the process, so that maybe is not exactly what you plan. We have an algorithmic design that is behind that adapt to this information. The information about the material, it's a flow of information it can deal with, it can adapt to it. And then the machine will be this mediator that is constantly in flow with the information. So while this diagram seems simple, is absolutely the opposite of what's happening today in the industry, where everything is really standard, pre-planned, and pre-thought. So there's no margin for errors, no margin for different type of material, no margin for natural material to be heterogeneous. And there's many questions and knowledge that have been disappearing in the name of standardization as mass productions. No? So actually, we know the circular economy will have a lot of problems to recycle products if we want to fit it in the traditional mass-produced industry. We need to make it more flexible to the material. So we've been doing a couple of projects around this, and I see that I have still 9 minutes to discuss quickly this project. I will go really through it quickly. Maybe to start with, a very simple type of process of fabrication is linked to pick and place. No, robot can easily like take an object and then process something. In this case, we're looking at a very simple circular saw that is able to cut a piece of wood and then place it into a kind of space on the side of the robot to be able to assemble. No, so just pick, process, deposit is something very classic in the industry, but generally it's the same process repeated millions of times. I don't know, my cell phone gets his 5 screws from the robot and then moves to the next line where another robot will take the next step. What's happening is today architects have the potential to program these robots for customized elements, so we can make that each tick is actually different in this process. And what we've done here is to actually take advantage of the flexibility of the prepping, of the cutting and assembly, so that we can deal really quickly with a wood that normally would be discarded. This was a wood that was ready for going for pallets, and so it was not a good quality wood because it came from the trees in Spain that are not so straight like as we have in Austria, because there's too much wind, there's too much valley. Basically, the wood is not good quality, considered good quality for construction. But they had a really nice trick that is to assemble really fast element and let them dry in place in a wet state. So we use actually the robot to produce very fast this pavilion in less than a day. In a day and a half, where we stack all these elements in a very redundant shape, where each sticks is maintained by at least 4 points, making that even if you try to twist, it will actually lock the entire shape. So this allowed us to use this material that's super cheap, that was going to be used as a way in another element into a building element, because we've been clever in the design, because we understand how to make it a bit more flexible, the fabrication process, and how to adapt finally to the material. But this was like us conceptually adapting the system to the materials. We can go to another step in this process where we actually start to scan and understand what kind of tree we have in front. In this case, we even try to scan it before we start to trim it into pieces, and try to understand where we could place and cut with a chainsaw, a small detail, a small assembly. So how can we streamline this process in such a way that actually you don't need to process the entire log into like straight beam and then recut this straight beam into your complex geometries, but you actually already acknowledge these complex geometries and you take it used into your building. And we've been doing many experiments like this, where we discovered that actually it's quite easy to integrate sensors, not necessarily in front of the robot, but sometimes we also fly drones directly in the forest to be able to pick the right tree and to understand what was happening. You know? And there's a huge amount of data we can track from both satellites all the way to actually us with field surveying the elements. This, at the end, we can store it in a database and we can stream this information into the design process so that we can choose which curvature we want where. If you're interested by this research, I invite you to look at also the wonderful work that's happening in Hook Park, where they've been doing this for many years. Very interesting, just specialized in the wood. But there's ways to look at it, not only at like trees as something natural and complex, but also look at waste as something that is ever changing, not streamlined, not really well organized. And we could use robots to actually scan them, process them, pick them, and sort them in such a way that it can become a building. No, actually, this is the research that has been going on now for more than 3 years, where we have discovered plenty of different algorithms to be able to adapt, scan, process, pick, place, cut, and quite complex elements that I will not go in detail now, but that brings very interesting feedback. The last iteration in this process was actually not having the robot to process the wood or the elements, but actually sending the robot on terrain, on the site, to be able to see what could be salvaged from a building, how we can process, extract material before we even take it out. We already knew what a building contains, which kind of information we can extract. And here we've been collaborating with a startup that's called Scale Robotics, specialized in digitalizing building sites, from two IAC alumni, with who we work really well in digitalizing this whole environment. No? So how can we actually design with these tools and integrate it? So here I would like to keep it a bit open because we don't have yet the directions this can go, but we believe there's a huge future to start to integrate building elements, recycled element or piece of furniture into our buildings, because we're able to give a bit more freedom, a bit more flexibility to our design as well as to the machines. So that's one line of direction we've been exploring recently. Another line is more linked to 3D printing, and we'll go really short because I've seen that just before you already had a lot about 3D printing. But we believe there's so much to be done here. And we've been inventing really weird materials mixed together with our colleagues. This, for example, this bioplastic with IIT, the Italian Institute of Technologies, very specialized in biomaterials. We've been looking at the right way to recycle orange peel or coffee grounds into a bioplastic that could be done. But again, here we try to be clever. No, the material in this case retract a very huge amount. I forget this is 5 or 10%, but quite strong element. And instead of fighting against this, and we try to fine tune with the material, we just acknowledge it, and we accepted that actually when we print flat, we let it dry and start to go into these double curve shapes that we start to find very interesting, and we start to design with it. We start to trace line. We try to compose with different type of material and try to find this new mechanism of designing this very efficient double curved shapes that came naturally from this drying process. And here there's a huge exploration still to be done. But the core of the research we've done the past 8 years was around this first project developed together with Enrico Dini of Pylos, 3D printing with earth, initially really dense in clay, and slowly we start to discover how with a couple of additives and aggregates we can actually improve how the material earth that is quite known. We're speaking about building technologies that exist for more than, I don't know, maybe 4,000 years, 5,000. The oldest building, I say, is 5,000 years old and still standing. 1/3 of the population is still living in earth constructions. But there will still be a lot to be done to be able to industrialize the process and to be able to make it more modern. No? So we started to develop the mix. We also looked at ways of developing new robotics for being to print on site. So here's a collaboration with Technalia on cable robots and how we could actually have these huge, massive printers that we can easily assemble and disassemble. It costs us 1 day to assemble and disassemble the structure, calibrate it, and then start to print. We also started to integrate drones to scan this huge scale and to be able to have feedback about how the material behaves and if we are good in precision. So these have been very interesting explorations. And then we started to look at like what this means for architectures. No? How can we look at all the details, how we can connect with the wood, how we can connect with ventilation, how we can put the insulation, how we can make prefabricated elements, or how we can print on site, how we can lower down the temperature by being more efficient in the way we distribute the wall. And certainly the architect is preoccupied by how we design the inside of the wall. That is something very interesting. We've been collaborating also with WASP, wonderful company that try to save the world Advancing Saving Project. in Italy, where together with them, we're looking at the possibility to have this printing on site with this kind of crane, where we've been also looking at new type of details, how we can make actually a straight wall that take stairs is actually not so easy, how we deal with gravity, how we deal with problematics of construction, no, in this new realm. And we've been developing a lot of methodology. Now I see that I run out a bit of time, so unfortunately we'll have to accelerate. Just mentioned that we have all the type of materials and experiments. I just wanted to show you quickly a small video about what we've been doing at 3D printing. I have a doubt if you hear the sound now. Maybe not. I don't think
a little bit. Yeah, we hear it. We hear it.
You hear?
Yeah. Can't hear you, Alexandro.
This video sound is better. So just to conclude, if you want to have more information, I really invite you to see the nice work of our students this year that are all touching similar topics and trying to explore where we can go with technology and architecture. They will be presenting this Friday morning, maybe a bit short for you during the workshop, but I clearly invite you to have a look. It will be publicly shared. Okay, with this, I say thank you for listening, and also thank you to all my collaborators that allows me to make such amazing work together with them. And I'm open to any question if you want. Thank you.
Great presentation, Alexandre. So just for you, for information, we opened up the conference to anybody who wanted to apply for it. So that's how it is.
We like to be open.
We're academics and we're supposed to share information. So this is where it's going. And I think what is very interesting today with the speakers, so we have two academic speakers, Christoph Gengnagel, working partially in private business, of course, and then you with the IAC, closely collaborating with a lot of companies. And tonight we have somebody from HAL Robotics. So it actually for this one day will be very in-depth into this kind of collaboration from the tools and utensils actually in a way that we use for creating new shapes. And I think there's some questions, but what I would be interested in is both of you have stressed the fact that you have a new model of working also with students. It was already a little bit discussion with Mette yesterday, is the way how we work for students and for students in the future. So a lot of what you're doing is called research. So it's real research with research partners, but it comes, if I am not mistaken, it comes immediately back with people that are actually studying at the school. So they are working on the research of other people, if I'm not mistaken. Is that correct?
Exactly. So we have these strange things. But first, you have to understand that actually half of the researchers of IAC have been ex-IAC alumni, but still IAC alumni, the ex-students. So we have already these first collisions. And then there's another thing that's happening is that the frontier between what I know after 10 years of research in these fields, plus my 10 years of geeking with technology before, actually sometimes, quite often, is challenged by new ideas from someone that just started to explore these technologies. No, so the discussion we tend to quite quickly forget who is the professors, to who is the students, who is the researcher, who is the industry, and it became like really this format of sharing. And I appreciate a lot a really horizontal space like IACS that actually confuse the skills. Also because I look young, I have often people asking me if I'm a student there, and I like to say that I keep staying a student for the past 10 years, and I'm enjoying to keep doing it in the future. So for me, I think that this distinction from who is learning to who is teaching, who is investigating in a format and at this level of studies, I find the confusion, the difference starting to erode, and for the better. Yet we have to put a bit of methodology in all of this to be sure that we start to keep our responsibilities. Let's say that when you deliver research, when you deliver building, when you deliver contents, there is this responsibility that is engaged and start to be a bit more complex. So we believe this is the best for ideation, for starting an ideas, but most probably then you need to transform this into a more professional frameworks as soon as you need to have like more deliverable, more engagement, with more responsibility on the functions and elements. And we are actually just starting a more collaboration and more format on these directions with the second year in the Master of Robotics, but also in other elements in how we can make this transition towards like a more professional framed research that you can take engagement, you can invest more because there is responsibility. But I really enjoyed this ideation phase that I think we should replicate a bit everywhere in the world in general, but I will really push for that.
It sounds interesting because in a classical teaching environment, it's not so easy to combine these things so thoroughly. And especially to have not only a bit of a Fab Lab space where people can construct, but also you need the part where you can test certain things like the materials itself, like the values. So you need close collaboration with other parts like engineering parts, but also on other things. So I think I've seen your works also from the school on fashion, so that's also quite interesting. I'm maybe going to ask some of the questions that arose during your presentation. So somebody was asking if they can use unstraight wood to build by the help of optimization and algorithm. I'm not sure what the unstraight wood would mean, but I suppose it's about the project that you had.
Curved.
Yes, but well, if we have unstraight wood, which would be curved, of course.
So I think, Guillaume, that you mentioned is like effectively now we have process and machines that like square stuff straight and process this more easily. But what is very interesting with this new paradigm that is emerging is that complexity became very accessible. Computational power is in the hands. Scripting allow us to deal and embed this complexity into simple mechanisms and simple design rules. And working with curved elements in terms of concepts and in terms of design is something now is easy to deal with. No, the NURBS software that we're using, in our case a lot Rhinoceros 3D, but any NURBS systems could work for splines and curves. So it's not so complicated for us to deal with curves. Then to be able to sort them or to organize them into a plane is a couple of algorithms that are not actually complex optimization systems. You will discover that some of them, just a sorting can be really powerful. If not, there is these genetic algorithms that are really, really well integrated in our systems to deal with it. And I think actually Hook Park have done a very nice project of this boiler room, not to be confused with electronic music, boiler room where they have integrated these curves in the process. And then another level of complexity comes into like, how do you handle curves into a robotic process or industrial process in general, because it's a bit more difficult to sort, to store, to place it in front of the robot, to grasp it, to clamp it, and then to be able to cut it. But it's not impossible. It's just we have to rethink a bit the way it's dealt. It's something that is very normal in the craft industry. They're used to work with curved element. Before the boat was actually taking like pieces from the curved trees to be able to place in the curved building or the curved boat. So there was a link between these things that manually we can understand, but then when we scale up to the scale of industry, we have to start to learn coding, scripting, and understanding a bit more deeply this process. I don't know if I answered the question.
Okay, thank you.
Sir, I think there's most of the questions are on the algorithmic part, of course. How do you get to that algorithmic knowledge, and how do you treat it, like for the upcycling project? Then also about somebody's asking if you can talk about the tools and softwares in digital fab. They're comparing that we're going towards totally parametric models like CATIA, whereas there I have a little remark, because in the 90s already, we used already extensively the CATIA for doing some pavilions and buildings, which was then brought into one project, Gary Technologies, and which is now not available anymore. So I think these, well, they're not, it's still available, but they're not updating it anymore. And it was a downspec of CATIA, and that's the problem, because all of these programs, if they start to become too complex, and if it's only about scripting, then I think you're losing part of the whole idea behind it, where an architect is also much into the visual, into the fabrication, and the engineer too, actually. It's a lot of imagination, and there we have to be careful not to put the code in front of, or to put the code at the right spot also. And then there was the last.
It's really clear on this aspect. The comment from actually the creator of the Grasshopper, David Rutten, when he wrote Grasshopper first, he on purpose, even if everything is open source, on purpose, it doesn't allow the designers to see the code behind each of the components, because he doesn't want people to be distracted, because you can always optimize your own component to be performing better. You can always rewrite the script. You can write algorithm for the machine to please and to be sure that everything works well. But you start to be distracted by your core. That is like, how can I develop quickly and intuitively my ideas, my logics? So I think the important bit in all of this is to feel comfortable with the technology as fast as possible and acknowledge the fact that it's never perfect. And this is something that we know when we sketch, then we know when we draw. We're used to this imperfection, to not have everything predefined. Something that sometimes people have been forgetting in the digital environment, with this availability to zoom in and out so precisely at every moment of design into your building. The same in the code, with going into all these layers of computations. I think it's important to be able to abstract this information, to be able to take out, understand the potential, but not getting drawn into it, so that we can actually connect with other disciplines. We're not computation scientists. We are people that use computation in a very pleasant way, in a very intuitive way, and places like IAC, Fab Labs, I believe, like the workshop you're doing, is to make comfortable people with these tools and understand the potential of it. But to rewrite them, I think they're specialized people that understand much deeper these problems, and to go into it.
I think it's much more about the logics of the thing, and I think there you touched a nice thing where you show you're coming from material to try to experience it. It's very much between experimenting in real scale and bringing that back to a digital level, which is enhancing rather the design and opening up perspective with what you've been doing. It's like, it's a very much bottom-up process coming from down, and then building up more knowledge whilst using it in the digital environment and then testing it around again. I mean, there's a wide range, like if as an architect or engineer, when you start with the first sketch towards a realization, which is maybe 2 years later, you haven't done any prototyping. Whereas in the academic world at the moment, we are experiencing that these worlds are getting much more closer. And even some architectural practices are doing much more prototyping in their offices and in their practice to learn from that to build again. And I think it's all kind of logical steps. I mean, if you analyze the guy that is putting bricks on top of each other, that of course brings you the knowledge how to do it with a robot. So there's a kind of, we're simulating the reality and then enhancing it by what the computer can do, of course. And I think it's a very interesting part because there's a lot of discussion there how if we should teach students also this kind, or even professionals, if we should just teach them the tools, or should we teach them the logics, or should we teach them the critical approach? It's an ongoing debate, and I think it's quite interesting.
And I don't know, our methodology and the way we've been dealing with it, most of us have been like self-taught before starting to actually get specialization in the master, like EACS ones or around the planet, have been like this kind of motivation, self-motivation for topics. No? So we discovered that we can teach as much as we want. It's much more important to show to people where we're going with this technology, where we are leading, and understanding the benefit of it and the interest that it could be directly for each of one of us. And then we will start to integrate these tools in our process. We will start to weave them into everyday elements, and then we'll start to push them to their limits. We have a lot of collaboration with industries that are watching us and looking at us like, oh, wow, you are so crazy with all this technology. How can we do it? No? And they seems to be very far from them. But we discovered that starting by small step of integration, a bit of small grasshopper component that solve this issue, or these elements that allows you to show the fabrication constraint of your system to the architect, or slowly but surely involving these things, have been a very good success in pushing slowly this evolution. So generally, we have like this one specialist in a bigger group, on a bigger office or industry, that start to weave this technology with the specific needs of this industry or the studios. And this is why it starts to be very powerful. So we don't believe it will be the solution that solves or change everything. We believe it will be plenty of small bits and pieces that slowly but surely will transform our industry.
Yeah, I think that's a good approach. Of course, it's incremental in a way. The other thing is that it's always the question of the egg and the hen, of course, which one was first. And I think in this case,
the human is first.
I always say that it's the architect pushing for new boundaries, but we can also say that it's maybe the industries that in the end will end up to push the architects to invent new forms and shapes and stuff. Because
from my experience, it was the architect that pushed for it. Generally saying, like, again, I have like an architect that came with this very beautiful project with a lot of millions, but I couldn't fabricate it because I didn't understand how to fabricate it. So generally, we have this type of industries that came to us. But who knows?
Yeah, but you see, I mean, there's a kind of democratization of the tools even in industries, and they will need it at some point to construct really nice and interesting stuff. And they will, as was prefabricated concrete, somehow an invention that suddenly changed the practice of architects. And until we're going to be able to move with all the architects in one direction, which is not necessarily necessary, of course. I mean, everybody has its own input there. But I think it could be interesting to see also since you guys with academics are working with some industries, they are bringing back knowledge to certain partners too, and to a certain extent are helping the democratization of certain tools. And then again, it comes maybe back to the architects that know, hey, this is available, we can use it now. So there's experiments going on from both sides, let's say, and it's not obvious which one is pushing the other one. And I think that's the only way how it could work. But the next generations of architects will still be taught in drawing rectilinear plans to solve housing problems, let's say. Yeah, and I think
straight line is still very good. Eh?
yes, of course. But I mean,
we discovered that sometimes curve is good, but line is also still square stuff. it's still a good future. I don't believe we'll suddenly have all wobbly shapes all the times.
Yeah, but that's an inherent problem of the first age I mean, we're maybe in the third how do you call it? The third Welle, the third Waage. How do you call it? Yeah, we're in the third period maybe of digital design in a certain sense, where and it's not only there in the beginning. It was there to try to solve complex shapes. Yeah, because we needed for the material to find tools how to get to the materials to produce them, and then to optimize. Then there's a second wave, which was in the maybe 10 years ago, where it's really people started to use the tools and make very complex shapes. But now actually all these parametric tools, we can use them for regular buildings, and actually they are very good for that too. And that's specifically what you say. Even on that particular scale, we can already do a lot with more industrialized designs, which will help our carbon footprint. And this is something we can maybe close with today. This discussion is, you both, Christoph and yourself, were talking about this carbon footprint. And I think this is really one of the major stuff that we all have to think about and how to do it. If the digital tools and the collaboration and the workflow are enhanced and improved, and that helps to reduce the carbon footprint, I guess I can only applaud for your work, of course.
So, let's construct bigger building now.
Yeah.
The small change is really little. I need to scale up, but I think we're on the way. And also, I see a start of change of conscience across the industry that is very interesting. I remember when I've been trained as an architect 15 years ago. My professors were telling me like, sustainability is not an option. It will be like by law, you will have to do it. So there is no escape possible. And I think that in France, they're starting to lead this. I heard that was like 50% of the public building will be in wood, and then there will be like an accounting, at least on reports of the CO2, the gray energy stored in building. So Europe will also, I think, push a lot with the Green Deal and start to actually ask accountings on buildings and understanding where all this energy is used. So this push from government hopefully will repercute on change of mentality really drastic in our industry, and hopefully therefore embracing easily changes and research and innovation in our system. So hopefully by then we'll have really convincing solutions to put on the table.
Okay, nice message. Okay,
I'm too optimistic, so be careful.
No, I think we're both positive and maybe slightly too positivist, which can also turn into the reverse, of course. But at least we're looking at a positive future, and that's what it's all about, also. And construction industry is a hard world, but my little experience is that positive attitude brings more positive people. So not necessarily more money. Agree. To make business, sometimes it's a bit more rough, but we have the chance to be in this academic research environment with industries that came to us because they also want to be in these positive changes. So hopefully we can create more and more this consortium, especially in Europe where collaboration is more easy, that our strengths come from speaking to each other, sharing, constructing, and making it happen. Because the enemy is not between us, is the people that doesn't care about energy and just want to make money. So I think there's potential to change this. I'm going to close down with this. So thank you to everybody for being there, and looking forward to Tristan Gobain from HAL Robotics. So I think that's going to add a nice layer. It's really nice speaker to have. And then tomorrow again, we have at 12 Lotte Aldinger and Stijn Brancard that will talk about active bending. Lotte is coming also from the studio from Achim Menges, or she worked with them very closely. Stijn Brancard from the University of Brussels. And then there's the office called Some People. So it's not a mistake, please. We'll be at 6 tomorrow. So see you later, people, at 6 tonight. Have a nice time. Thanks, Alexander. See you soon.
Thank you very much.
Bye.
Good luck with the workshop.